Okay, good afternoon, folks, and welcome to the Institute of Education Masterclasses. Now, first of all, my name is Aidan Roantree, and I'm a senior maths teacher in the Institute of Education, and I teach in the day school. I teach in some online courses for the Institute, and indeed live on a Saturday morning. And that's relevant because, again, many apologies for the fact that the class had to be postponed from earlier, from 2 o'clock. I was in the institute this morning taking classes, and I was meant to be set up, and they were setting me up to have this class, this master class from the institute. But unfortunately, there was a glitch with the IT equipment. So what I did is I ran home, and I'm on the equipment that I use at home for giving the online classes midweek. On behalf of the institute. So that's me. I'm going to get off the screen. But actually, just before I do, just to tell you what my brief was. The brief that I was given for today was to talk to you about examination technique and parameters of exams, of the maths exam in general. And as we go through that, to use some examples from past papers to highlight issues. And we're going to be doing exactly that. This, as you may have seen there on the screen, this class is being recorded, so you should be able to access it again later if there's anything you want to see again. So, yeah, if you have any questions, you can type them into chat. I'm just going to go back now, and I'm going to get this off the screen, and we're going to start off. So, in the beginning, there's going to be issues concerned with exams, and then we'll start looking at specific ideas that are going to that we can highlight by means of exam questions from the past. So, we're going to talk about exam technique. Um, yeah, there. If somebody's asked, can the screen be made bigger? That is controllable from your end. Okay, you have to pin it exactly. Okay, you have to pin it, right? Now, so I'm just going to put down here, first of all, overall considerations. Now, the first thing I'm just going to talk about is timing. Now, just very, very briefly, I'm sure you've experienced this, but as you know from your mock exams, each maths paper consists of two sections, section A and section B, and you have to answer in section A. You have to answer 5 questions from 6. Sorry, just 1 second now. 5 from 6, just 1 second. Now, each question then is 30 marks, which gives you 5 by 30, which is 150. And then section B, you have to answer 3 from 4. And section B, 3 from 4. And that's going to be 3 by 50. And that's another 150, giving a total, as you can see, of 300. Now, how does this affect the timing? It's very simple. In the exam, the time is 150 minutes, 2.5 hours. Okay, 150 minutes. So you can do a very simple calculation to see how many marks you should be getting each minute if you're on track. So basically, the simple calculation is 300 divided by 150, and that gives you 2 marks per minute. Now, that's a really, really handy little check for determining how long you can afford to spend on each question. And sometimes, if you can guess the number of marks going for each question part, you can also estimate the amount of time you can afford to spend on each question part. So, for example, a section A question, which is 30 marks, right? Section A question, which is 30 marks. What you can afford to spend, the maximum amount of time actually, is 30 marks divided by 2, and that's 15 minutes. And for a section B question, which is 50 marks, clearly that's going to be 50 divided by 2, which is 25 minutes. Now, it is really important that you realize that these numbers are absolutely maximum numbers. You should not spend any more than that length of time on each section A or section B question. And if you can, it would be a very good idea if you could do some of them at least in less time than you have here. Now, just one practical consideration, and that is that some people, because it can be very easy to say as you go through an exam, what time did I start that? Oh, I forget. What some people do is that they actually jot down on their exam paper, right, the time at which they're due to finish that. So, for example, if you're doing a section A question and you look at your watch or your whatever, yeah, and it's 12 minutes past 10, and you've got 15 minutes that you know that you can do. So you add 15 onto that, and that gives you 10:27. So what some people do is they jot down 10:27, and that tells them that that is the final time. And if that time arrives and they're still on that question, it's time to move on. Under no circumstances should you go on beyond that. Okay, now the next thing, okay, is question choice. Now, we've been through the number of questions that you must do in each section, okay, over here already when we were talking about timing. So, in what order, basically, should you do, right, the questions? Well, the first thing is, I'm not going to write it down, but you should definitely, obviously, read all the questions, right, in each section before you make any decisions. And after that, probably the best advice is to rank the questions. That means put them in order of your favorite to your least favorite. And I'll give you an example. Suppose in a particular section A where there are 6 questions, okay, that you go through them and you look at them: question 1, question 2, question 3, question 4, question 5, and question 6. And let's suppose you think the easiest one for you is question 3. So you can just make a note that that's your first preference. And then let's suppose question 5 is your next. All right. And then let's say number 1 is your third preference. And let's say number 6 is your fourth preference. And then we'll say number 5. It could be any order. This is just one possible order. Fifth and then sixth. And then the idea is always, always tackle the questions in the order of your preference. There's a good few reasons for this. Number 1 is that if you tackle them in order of your preference, hopefully you'll be very good at the ones that are top of your list, and you'll be piling up the marks as you do that. But just as important as that, you'll be gaining confidence. And that's really, really important when you're doing that. Okay, the other thing too, tying in what I said over there, the first couple of questions on your list, the ones that you find the best, you should be trying to put in the bank some minutes from those questions. Do them in less than the 15 or the 25, depending on what time it is. Okay, you should be trying to bank a few minutes for that. Now, and then of course, maybe you kind of made a mistake in your ranking here. Maybe you get to question 6 and ooh, it's not as easy as you thought. Well, then the main thing is say, okay, I'll leave that for the moment. Go on to my next ranked, which is number 2, and then at the end we'll make a decision there and we'll decide what we're going to do. Okay, so that's that one. Now, the next thing, and tied in with that, okay, number 3 is the number of questions to tackle. Okay, the number of questions to tackle. Now, in theory, you should only tackle the required number of questions in each section. So in section A on each paper, you should try and do 5, and in section B, you should try and do 3. Okay. However, if you think that you've not done particularly well in one of the questions that is on is from those that you've done, you might think about doing as kind of, if you like, an insurance policy. You might think of doing the final question in that section. Okay. Now, But this is always a delicate issue. Do you do that? Do you kind of say, okay, I did a very bad question, say 2, right? I'm going to do question whatever it is 4 instead of that. Or do you go and try and fix question 2? And this is always a delicate decision. It might be, depending. I mean, it's very easy to give up quickly on a question and go and do something else. It might be more worthwhile and indeed more productive to spend any leftover time that you have on the original question that you've not finished. But I'm not going to make that a rule. I'm just going to say that this is a judgment call that you're going to have to make on the day. Basically, it'll depend on how badly you did the question that you think you messed up, and how well you think you would do within the time. Don't forget that you're starting from scratch with the alternative question. Right, okay, so that's some of these. Now, the next thing is I want to talk about, okay, number 4 is the marking scheme. And now many people are very focused on the marking scheme, and it can vary from year to year, vary from year to year. Now, and I'm just going to say a few things about this. I'm going to say, first of all, it's important not to become too fixated on wondering how many marks you will get, or indeed how many marks you will lose for a particular effort at a question. And the main reason for not worrying too much about this is because, first of all, it'll eat up time in the exam. But secondly, right, the marks gained and lost can vary from year to year. You've got to bear in mind that the overall consideration each year is to try and turn out roughly the same number of H1s, H2s, H3, and so on, as has occurred in previous years. In other words, the famous bell-shaped curve. And this means that in a year when a paper is difficult, questions will be marked in a very generous way. But on the other hand, when a paper is seen to be easy, it'll be marked in a stricter, sometimes a far stricter way. Now, I'm often asked then by the students in school, well, if you were doing the Leaving Cert, okay, this year, how would you balance that? How would you you know, kind of take that into account? And my answer always is that my attitude to all questions as I would go through them, if I was doing it in the Leaving Cert this year, would be to give the examiners as few opportunities as possible to take marks off me. In other words, within reason, try and carry out everything that I think might be required, okay, and to watch little things as well. So sometimes people are disappointed afterwards to say, oh, I left out units. Oh, I didn't realize you could lose marks for that, and so on. Well, you can, and these are the things to be aware of. So now what we've just seen there are some of the overall, if you like, the broad considerations. So now we're going to move on to the idea of answering questions. Sorry, just let me have a look here. I can't keep on viewing the chats. I have to keep going with. So, yeah, yeah. If you answer 6, do they take your best 5? Absolutely. Yes, they do. Okay. Yes, they do here. Right. Okay. Now, so this is answering, okay, questions. Now, there's a few things that we're going to talk about here, and as we go through this, with some of these, I'll be taking examples from past papers, and I'll be putting the year and the question number up on the screen, and then we'll be having a look at the question. So the first thing here is reading the question. Okay, now don't gloss through it and imagine. This is very, very common that you say, oh, it looks like a question I saw before, and I think they're asking for this. No, read it carefully, line by line. And indeed, what some people do, okay, read each question that you've decided to tackle carefully. But what some people do is that they underline, they go through it carefully and they underline crucial verbs like explain, prove, solve, differentiate, and indeed sometimes some nouns, okay, like equation. Okay, if you're asked to get an equation, that doesn't mean an expression, it means an equation. And instructions as well, things like give your answer correct to 2 decimal places. So people very often, I often see when I'm marking exams, things like that underlined, and it just means that the person is trying to stay focused. So I wouldn't knock it. I'm not saying it's for everybody, but it's certainly for those whom it suits, it is a good idea. Okay. The second thing then is tackling a question. Now, most questions, in fact, I think we can safely say all questions have multiple parts, right? A, B, C, or A part one and part two, and maybe B part one and part two, or maybe just part one, part two, part three, part four, and so on. It is important to recognize that when you start tackling a question, that you are under no obligation whatsoever to answer the parts in the given order. And this is made easier by the fact that, as you know, when you've looked at maths examination booklets, that there's an answering space, a separate answering space underneath each part of each question. Now, so if they're separate, and especially if they're separate, if you think that the B part of a question is nicer and is easier than the A part, well, again, with the idea of gaining confidence in mind, it might be a good idea to go and do the B part first. Now, it says then here, I'm just going to say, if you think, then answer the A part. Now, of course, sorry, the one thing I meant to say about that is that of course, assumes that you don't need an answer from the A part to help you tackle the B part. Right, okay, but that goes without saying. You're under no obligation to do that. Now, the third point here is give an answer, okay, to each part of every question that you've chosen to do. Every chosen question. Now, even if you think that you haven't got a clue as to what exactly they're asking, take a guess. Take a guess. It is important that you make some attempt at each part of each question. And the reason is, look, what's the worst that can happen? The worst is that can happen is that you make a wrong assessment of what they're looking for, or you know what they're looking for, but you go about it in the wrong way. Either way, the worst that will happen is that you get 0 marks for that part. And usually, if you've got anything at all right at all, you will pick up at least the low partial credit, and very often more. So if you've decided to do a question, for example, question 3, and it has an A part 1 and an A part 2, and a B part 1 and a B part 2, right? Even if you think that one of those or maybe two of those, you do, excuse me, you don't know what's going on, give it a go. Give it a best guess as to what's going on. Now, I will just say that sometimes that you look at it and you say, well, I needed the answer to part A, part 1 to do part A, part 2, and I don't have the answer. I couldn't finish that out, and I don't have the answer to part A, part 1. Well, what you can do then is that you can take a good guess, okay, a good guess at, oh, sorry, I've got another question there. I'll come back to that in a minute. Okay, a good guess as to what the answer should be. And then if you use, okay, if you use um, the method correctly, even though the value is wrong, you will get a huge portion of the credit for that. Now, a question in the chat there was, what if you do it 2 different ways? Okay, will they take the better one? Yes, they will, unless it's a question to choose. For example, if a question asks you, is a function surjective? And you write down, yes, it is here, and no, it's not there, you're going to get nothing for that. Okay, because you're being asked to choose which one it is, and the examiner doesn't know what your choice is. But if you're asked to work something out and you work it out more than once, well, then you will get credit for that. Okay, now, so if you haven't got a value for a previous part that you need to use in the next part, take a guess, take a reasonable guess with it and go on and use it. Now, part 4 here is simplify. Point number 4 here is simplify your answer. Okay, simplify your answer. Now, the instructions inside the Leaving Cert answer booklet include the following instruction. It says, you may lose marks if your answer, okay, you may lose marks if your answers are not given in simplest form where relevant. Okay, now, okay, I've been asked a question. Can you go through the order and how to tackle the paper, as in which kind of ones to start with first? Now, I've talked about it from the point of view of your preferences. And the thing there is that one person's preferences differ greatly from another, right? Okay, preference. Would I another question there quickly? I'm going to put some of these questions on ice because otherwise we're not going to make any progress here, and I'll come back to them at the end. Okay, now this is the last one I'm doing for the moment, but keep typing them in. I'll come back to them later. Um, trial and error. Trial and error in an odd case will work, but most of the time they're looking for the method. And if you have the method right, even if you don't get the final answer correct, you'll still do very well. So as I was saying there about simplify your answer, it says in the Leaving Cert booklet, in the instructions on the inside cover, it says you may lose marks if your answers are not given in the simplest form where relevant. And because that's there, that is used in the marking conference as a reason to take off marks where a student doesn't tidy up the answer. Okay, so don't ignore this. If the answer to a question part is an expression, okay, an algebraic expression or some kind of trigonometric expression or something like that, ask yourself if it can be improved. And then if it can be improved, if the appearance can be improved within reason, then you should do so. Now, the next point here, number 5, is be neat and organized. So be neat and organized. And I just put down here where possible. I'm just say it. I won't write it down. Where possible. And I'm just going to say on this point here, right? Although there are no marks being awarded for neatness, it should come as no surprise that there is a high correlation between neatness and excellent marks in a maths exam. And the main reason for this is because when you're neat, it tends to lead to more accurate work and therefore higher marks. So if you are constantly crossing things out and moving all over the page with your work, it's very easy for you to lose track of what's going on and what you're doing. And for that reason, it's much easier to make a mistake, and it happens all the time. It's also very hard at times for the examiner to follow your logic. And they're not obliged to read your mind. The onus is on you to communicate, to make it clear to the examiner what you intend. And if they can't follow you, well, then they're not going to be able to give you marks. Now, just on this score here, ideally, you should work in a linear fashion, which means straight down a page, only very seldom go over to the side, right? And going line by line. It just means that you are following a logical sequence as well. Okay. I know, I mean, you're at 6th year stage. You've been doing maths all the way through secondary school and an easier version of maths in primary school and so on. And some people don't work like that. I fully understand that. Okay. And it's very late in the day if you've been doing using a particular approach for years and years and years to try and get you to change. But for your own sake, if you can, within reason, if it's not too much, okay, then try and be within your own constraints. Try and be as organized as you can. Okay, for that. Now, and if you are more organized, it's likely to result in higher marks. And there's a few things here that I just want to say about people's practice in writing down maths. One of them is that one of the most notorious situations is people not treating an equal to sign with respect. An equal to sign, if you've got an equal to sign in a statement, that A is equal to B. And if you want to say then that in turn that's equal to something else, you can either say A is equal to, for example, C, or then you can put down equals C. You see, an awful lot of people, when they're doing maths, writing down what we call mathematical islands. They're expressions that are not connected to anything, whereas they should actually be equations. They should be equal to things. Now, within reason, they will get marks for what they've got that's correct. But when you have to start transposing terms, bringing terms from one side to the other side and rearranging, you need the discipline of seeing where the equal to sign is so that you can bring things over in a safe way. Okay, and all I'll say again is people who are careless with equal to signs tend to make more mistakes than those who do them correctly. Okay, now the next point that we're going to talk about here, point number 6, is to know the difference between hence or hence or otherwise. Now, if a question says hence, that means that to answer the part that you're currently on that follows the hence, you must use what went before. Okay? If you don't, if you say, well, I don't like doing it that way, I prefer to do it another way, it depends on the year, it depends on the marking scheme. You may get a couple of marks, you may get a low partial credit, but equally well, if it's an easy paper, you may get nothing. If they say hence, they mean you to do it by the method from before. It's the method they're examining. They're not looking for the answer. There's no point in you turning around later and saying, well, by doing it another way, I did get the answer. Their attitude is yes, but we weren't looking for the answer. We were looking for the student to show us that they could use the method. And that's why if they say hence, okay, stick with that. Hence or otherwise is different. Hence is saying, well, you can use what went before, or you can do it another way if you can find another way. But usually when they say that they've worked it out prior to this, that the word hence is the one to use by and large, because they're trying to, if you like, give you a hint as to what the easiest way of doing the question is. Now, if you don't see it, there's no problem. If you can think of, if you can spot another way of doing it, well, then you can do it that way as well. Okay, another method will be fine. But be very, very clear. If I saw either of those in the exam, I would make very, very sure that I knew which one it was. Am I obliged to use what went before, or have I the freedom to either use what went before or use some other method? That's what I'd like to know there for that. Right, okay, so that's that. Know the difference between those. Now, the next point here is be careful, okay, with accuracy, right, and units. So you know what I mean by accuracy. They might say give the answer correct to the nearest whole number or integer, or give it correct to one or two decimal places, or give it, for example, to two significant figures. Okay, and again, the units, particularly in questions where there are lengths and times and stuff like that, for example, speed, meters per second, or whatever it is. Okay, look, when I'm about to walk away from a question in maths, I always ask myself, is it appropriate to put units in here? Do I need to put units into this? Okay, to see what's going on. Now, I often get asked, okay, again about marks. How many marks do you lose if you don't have the correct accuracy or if you leave out the units? Well, in a very, very hard paper, they might not insist on this at all. You might lose nothing, but you can't bank on that. And if the paper is fair or easy, you will lose marks. Now, for either or, they tend to just penalize one mark. And I'm just going to give you an example here. It's not too bad. Suppose there's a question that has an A part 1 and an A part 2 and an A part 3. Okay, and it has a B part 1 and let's say a B part 2. Now, and let's suppose that they've asked for all the answers to all these parts to be given correct to, let's say, two decimal places, and you don't. You don't give the answer to 2 decimal places in this first part here. So that will be -1. Okay, you lose 1 mark for that. And then let's suppose you don't do it again here and you don't do it again here. Now, the good news is they don't penalize within the same section. They don't penalize, okay, one of these mistakes more than once. So even if you don't use 2 decimal places there and 2 decimal places there, the maximum deduction will be 1 mark for that. But let's suppose then that you go on to the B part. And in the B part, okay, you leave out the units there. That is -1 there. And you leave out the units here. Again, they're not going to penalize you again. So these deductions are made at most once in any given question section. That means A, B, and these are subsections here. So they'll only penalize you once here. Right. Now, the next point, from here onwards, now we're going to start using examples. Okay, so I'm going to be doing some questions out. The next one, and I'm going to be putting them up on the screen here, is I've noticed over the years in exam questions, the minute that a Leaving Cert question asks you to explain something, the standard of answering goes through the floor. Okay, and the reason is because people write down some stuff fair enough, but they don't actually explain what the question is looking for. Now, I'm going to give you an example of this. I've got a good few other examples to go through here. And the example, and you can just see it. I'm going to move this over here. Actually, yeah, I'll just move this here and I'll do it. So the question I'm going to put up on the screen here, I don't know if you can see this. I'll call it out. Okay. It says it's from 2022, paper 1, question 1B. And it says, explain why the following equation in X has no real solutions. Right. I'll write it bigger so people can see it. Okay. And then we'll do the question here. Now, the equation that they've given us here is this one. So it's 2x plus 3 to be squared plus 7 is equal to 0. And the crucial thing here is, and if you look at the question carefully, even if you can't see it here on the screen, you know where you get it, right, from the examinations.ie. But it asks you to explain, there's that word explain, why it has no real solutions. Okay, well, one thing we could do here is try and solve it and see what happens. So we can say here that if you expand that out, this is what we call a binomial, 2 terms in a bracket to be squared. And the quick way of doing that is to square the first term. So if you square 2x, you get 4x squared. Then you go first by second, which is 6x, and then you double that, so you get 12x. And then you get 3 squared, you square the second, and that gives you 9. And then you've got plus 7, and that's equal to 0. Now, if you tidy that up, you get 4x squared plus 12x, and then 9 and 7 is 16. Fair enough. Actually, looking at all the, and see the way I'm keeping the equal to sign here all the way down? The other thing is that all the coefficients here on the left-hand side are divisible by 4. We can tidy that up by dividing across by 4. We get x squared plus 3x plus 4 is equal to 0. Now what I can do with that is I can start to use the minus b formula. And for this here, a is going to be 1. I'll just put it over here. A is 1, b is 3, and c is 4. And therefore, from that, x is equal to, right, minus b would be minus 3, plus or minus, okay, the square root of 3, that's b, 3 squared minus 4 by 1 by c, which is 4. And then that's all over 2a, which is 2 times 1. And that gives us x is equal to minus 3 plus or minus the square root, okay, of 3 squared is 9, and then minus 4 by 1 is minus 4 by 4 is minus 16. 9 minus 16 is minus 7 over 2 times 1 is 2. Now, they've asked for an explanation. I think I can see, I understand, and I'm sure you do too, why the roots of this, the values of x here, are not real. But we need to show them that we understand. You might say it's obvious to anybody. You may think that the fact that the roots are not real here is obvious to anybody. But I'll tell you what's not obvious. It's not obvious that you know. And you must leave the examiner in no doubt that you know what it is. So what I'm going to say here for this is that the values of x, these values of x, okay, are not real. Why? Because the square root of -7 is not real. Okay, so now they know that you know the reason why that's not real, and that's what you need to write down. You must stay away. And whenever I see the word explain, I say to myself, I want to make sure that the examiner knows full well that I know the reason why. Okay, and that's the main thing there for that. Right, now explain why. That's that. Actually, interestingly, there was a shorter way of doing that question there. Okay, the shorter way was to say 2x plus 3 to be squared plus 7 is equal to 0. And therefore, from that, 2x plus 3 to be squared is equal to -7. Now, if that's correct, well then 2x plus 3 on its own will be equal to plus or minus the square root of -7. And then you could give the same explanation here. The values of x here cannot be real because the square root of -7 is not real. So it was an alternative way. That's a point that we're going to come back to again because many Leaving Cert questions have a variety of different ways that you can go about doing them. So that was point number 8, explain. Right, now, and a similar term to point number 8 then is to demonstrate, and they may say show, or they may say prove, which is slightly stronger. Demonstrate or show, okay, or prove. And again, there must be no kind of weaknesses in the chain of logic that you give them when you're doing this. Just let me have a look at this for a second. Yeah, okay. I've been asked about simplifying to decimal places and intermediate values. Good question. They're usually quite forgiving on that, but the rule of thumb is that you keep the intermediate values to one extra digit. So if you're looking for 2 decimal places at the end, try and keep the intermediate values to 3. Okay, so that's that one there. Now, I'm just going to have a look at a question here, which is a trig question. That's an algebra one that we've just done there. So the trig question is going to go like this. And it's from 2022, like that one there, but it's from paper 2. And I'll write it down here. Okay, so it's from 2022, paper 2, question 4a, part 1. And they asked you to prove that. And I'm going to write it down again. This is what they've asked you to prove, that tan of a minus b is equal to tan a minus tan b. Just writing it larger so everybody can see it. Over 1 plus tan A, tan B. Now, of the trig identities, or trig formulae as some people call them, doesn't matter what you call them, okay, that are in the maths tables on pages 13, 14, 15, and 16, okay, there's only 8 of them. If you look at the syllabus and look at it carefully, there's only 8 of them that you have to learn the proofs of beforehand. And the 8 are cos squared a plus sine squared a is equal to 1. That's number 1. Number 2 is the proof of the sine rule, which is there. Number 3 is the proof of the cosine rule, which is here. Number 4 is cosine of a minus b. Number 5 is cosine of a plus b. Number 6 is cosine 2a. Now, as they're numbered in the appendix at the back of the syllabus, number 7 is sine of A plus B. And then the last one, funny enough, is numbered number 9, and it's this one here. Now, the interesting point is that although some of the textbooks have this one here in them, you're not required to have learnt that one off. So anyone that's in the maths tables here that's not one of the 8, or anyone that's not in the maths tables at all, is called an unseen trig formula or trig identity. And if you have to prove it, you are allowed to use anything else from the maths tables. So we're asked to prove this. So what we can do here is that we can start from one side or the other side and try and get to whichever side we start with, we try and get to the other side from that. Now, as I said, we are allowed, and this is very important, we are allowed to use anything else from the maths tables in the trig pages here to do this. So I'll show you what I'm going to do with this. I'm going to say tan of A minus B. This is the left-hand side. That's where I'm starting from. That's equal to tan of A plus minus B. Now, we are allowed to use this one because it's in the maths tables and we're not being asked to prove it. This is the one we're being asked to prove, this one here. Now, if I used the tan of A plus B formula, I can write this down, and that's going to be tan of the first, which is A, plus tan of the second, which is minus B, over 1, according to this, 1 minus tan of the first, which is A, multiplied by tan of the second, which is minus B. Now, how can we deal with that? Well, if you go back and you look at the previous page, okay, it tells you there on page 13 of the maths tables that tan of minus A is equal to minus tan A. Now, the angle A could be anything. Tan of minus X is equal to minus tan X. Tan of minus B, in our case here, is equal to minus tan B. So we can use that to deal with the second part of the top line and the end of the bottom line as well. So we can write that down as tan of A plus, and then instead of tan of minus B, we get minus tan B. And then on the bottom line, we get 1 minus tan A multiplied by, and tan of minus B again can be written down as minus tan B. And now if we just take the brackets, the square brackets away, we can just tidy up and finish. Tan of A plus minus is minus, so you get tan A minus tan B. Okay, over, and then on the bottom line, you've got minus tan A multiplied by what's inside the brackets, which is minus tan B. And that's going to be minus by minus is plus. So you get 1 plus tan A tan B for that. Now, that's just one way of doing it. There is another way, which is very reminiscent of, in fact, the proof that you would have learnt as number 9, where you write tan of A minus B as sine of A minus B over cos of A minus B, and then divide above and below by cos A cos B. This is probably a quicker and shorter way of doing it, but it's much of a muchness. But you must go through it. There must be no break, and especially because the actual answer is given in the question. If you leave out something, because anybody can cheat and just write down the answer, it must be that the examiner must be able to follow your logic all the way down, okay, to make sure that you're fully explaining. Basically, you're trying to convince the examiner you're not cheating, okay, that you're not just, because the answer is there. At any stage, if I get stuck, I can write down equals that, okay, and you know, the examiner will be on the lookout for that, okay, so you must be very, very careful with that. Now, the next point here I'm just going to make is that, as we've seen already in some of the examples that we've done, that there are multiple possible methods for many, many, many questions. Okay, now, and Obviously, if you have any correct method for going through it, they'll give you the marks for it. Okay. Um, Now, okay. So try and think of a reasonable. I mean, obviously, rely on the kind of approach that you took in school if you can remember what you did in a similar question. But I'm just going to warn people, okay, that every single year in the Leaving Cert, they do their utmost to make as many parts of the questions as possible look different. So you're going to have to look at the question and try and decide what's going on and try and come up with a reasonable, right, approach that you can try, that you can plan out on this. So we're going to have a look, okay, at a question, right, that I'm looking at here, and I'm saying, yeah, okay, we didn't quite maybe do one exactly the same as this in school, but how could I do it? Okay, it's on the paper. And it's this one here. And again, the writing is fairly small. I'll make it bigger. It's from the 2024 paper, paper 1, question 6A. Okay, now in this question here, it gives you a quadratic polynomial, which it refers to as h of x. And it says h of x is x squared plus bx minus 12. And then the question says, find the value of b if x minus 4, okay, is a constant. Sorry, is a factor. B is a constant, is a factor of that. Okay, of h of x. Now, what I can do here is I'm just going to say method 1. I realize, okay, that if x minus 4 is a factor of that, the other factor will be x minus something or x plus something to give me x squared at the beginning. And now I can say, well, to get x squared at the beginning, it has to be a single x. X by x will give x squared. But the number in the second bracket is going to be what I would need to multiply minus 4 by to get minus 12. And that would have to be plus 3. Okay, and you can check that. X by x at the beginning gives you x squared. And then minus 4 by plus 3 at the end gives you minus 12. And now, if we work this out, we may be able to identify b from that. And if we do, we get x by x is x squared. X by 3 is 3x. Then we get minus 4 by x is minus 4x and minus 12. And then if we gather like terms then in the middle, plus 3x minus 4x, that's minus x, minus 12. Now, if you compare, this is called the principle of undetermined coefficients, but when one polynomial is equal to another, we can match up the corresponding coefficients. So yes, 1 is equal to 1 at the beginning, minus 12 is equal to minus 12 at the end. But the one we're interested in is that the coefficient of x in the first on the left hand side must be equal to the coefficient of x on the right hand side. And that will be that b is then equal to minus 1. Okay, so b is equal to minus 1. So that's one way of doing it. Finding the other factor then by inspection. Now, the second way I can say is, well, if x minus 4 is a factor of h of x, I know from my algebra that if I divide x minus 4 into that, then the remainder has to be 0. So what we can do here is that we can set up the division sum either way, the traditional way or by the array method, whatever you want to use, doesn't matter. Okay, and we can divide in by x minus 4. So here we go. Looking at this, we can say x by what will give you x squared? The answer is x. Okay, and then if we multiply the divisor by x, we get x squared minus 4x. Now, I think most people know the way long division goes. In theory, you're meant to subtract that line from a line above it, but in practice, what we do, instead of subtracting, is that we change the signs and add. That has the same effect as subtracting. Okay, Good. Now, then that will cancel with that. That's the whole idea. And then if we add these two terms here, taking the x out as a common factor, the number of x is b plus 4 times x. Okay, b plus 4 times x, and then minus 12. Okay, now, if we have a look at this, then we have to say, right, now, if whatever we multiply this by, you could go by b plus 4, but the clever way of doing this is to say, I know what's going to happen at the end. At the end down there, the remainder has to be 0, if indeed, as we're told in the question, this here is a factor. And that means that whatever we put here and multiply by that, it has to match this. Therefore, this has to be a plus 3 to make the 12 match at the end. So if we get from that there 3x and then minus 12. Now, for the remainder to be 0, this is very important in long division sums like this, without actually changing the signs and adding. There's a quicker way of doing it than that. The quicker way is to say that for the remainder to be 0, when you subtract that line from that line, these two lines must be identical. They must be exactly the same. Now, obviously, the minus 12 and the minus 12, they're the same, so there's nothing to be gained by writing that down. But we can match up then the coefficients of x, and that gives us that b plus 4 is equal to 3. And if you bring the 4 over to the far side, b is equal to minus 1. And there's the same answer got in a different way. And there's another way as well, right? If you remember from when you were doing cubics, the factor theorem, and the factor theorem, but the factor theorem can be applied to all polynomials, not just cubics, including to quadratics. We can say that x minus k is a factor of a polynomial f of x, right? If f of k is equal to 0. And it's primarily used with cubics, but it can be used here as well. If x minus 4 is a factor of and that's the background, but if x minus 4 is a factor of h of x, then to find out what number we should put in place of x here and put it equal to 0, the quick way that most people do is that they go over to the side, or just do it in their heads, by the way. They put the factor equal to 0 and they solve that for x. So if x minus 4 is equal to 0, well then x is equal to 4. Why does that work? Well, if you put x minus k equal to 0, then you get x is equal to k, and that's the number that you put in. So if x minus 4 is a factor, that means then that h of 4 is equal to 0. And if we put 4 in there for x, we're going to get 4 squared for that, plus b times 4 minus 12 is equal to 0. And we can just work that out. 4 squared is 16, plus 4b minus 12 is equal to 0. And that's going to be 16 minus 12 is 4. 4 plus 4b is equal to 0. 4b then is equal to minus 4, and therefore b is equal to minus 1. And yet again, there you have the same answer. So whichever of the methods, and they're quite different, whichever of the methods that you use, as long as you pick one of them, okay, then you'll be able to just say, okay, I think this method works. Give it a go. And if you've made a mistake, well, then hopefully you'll have enough time to be able to go back and say, what other way is there of doing this question here? Right. Okay. Now, the next thing is I'm going to go on for a little while longer, and then I'll just, are there any more questions? No more questions at the moment in the chat, but I will open it up to any questions that people have. The next point here, number 11. Okay, and I'll just say here, especially in section B. Section B, as I'm sure you know, they're the long questions at the end of each paper, right? The 50-mark questions. But especially in section B, questions can range can range over many topics. And it's one of the reasons why you're not really encouraged to go through past paper questions until near the end of sixth year when you've got all the topics covered. Because one of the big issues that you're going to have with every one of those long involved questions is deciding, okay, what's the appropriate approach? And unless you have all the different tools in your bag, you're not going to be able to know what you could use. So I'm just going to say, especially in section B, okay, it's not a great idea to label a question as an algebra question or a trig question or probability question because they can range over so many different ideas here. Now, I'm going to have a look at one of the, there's lots of famous ones, but we're going to take one. Okay, and it's from last year's paper, and it's a section B question. It's question 10, okay, on section B from last year, paper one. I'll just put it up on the screen here now. Okay, I might put it there. So it's 2024, paper one, question 10. Now, it goes down through part A, part one, and part two. Then there's a part B. Okay, then there's a part C, part one and part two. And then there's a part D at the very end. And it covers a huge range of different things. Now, the introduction to the question, I'm sure you can't see that, but you'll be able to look it up on the examinations.ie. But it says a company, I'll just put this down here, 2024, paper one, question 10. Okay, now it says a company grows and sells plants. And in the A part, it says that the function W, which can be used to model the height of a particular type of plant, a water spinach plant, is given by this. So W of X is equal to 0.667x plus 1.5 x squared minus 0.025 x cubed. And it says here x is the number of days after the plant starts to grow. And then it says x is between 0 and 35. Okay, so it grows for 35 days. And then the first part of the question, okay, asks us to work out the value of w of x when after 15 days. So they want us to work out w of 15. Is it as easy as that? That's in excuse me. It says here that this is in millimeters. Okay. Is it as easy as that? That you just put 15 in there in place of x on a calculator and work it out? And the answer is yes. Now, I'm looking at that question and I'm just wondering how many marks are going for that? And the answer is probably just 5. But it's 5 marks we should be able to pick up very quickly. So I can go 0.667 multiplied by 15, and then it's plus 1.5 by 15 squared, and then it's minus 0.025 by 15 cubed. And then I just hit equal to, it comes back like this, 263.13, okay? And it says give your answer correct to the nearest millimeter. So on the calculator, that's going to be 263, okay, to the nearest whole number. It's 263 millimeters. Okay, so that's fine. You're picking up an initial number of marks for basically just evaluating a polynomial, putting a value in. The second part of this then asks you to work out w dash of x, which means the derivative. And that just means differentiating this. Now, that's not that difficult because it's only a polynomial. When you differentiate a number of x, you just get the number. So 0.667. Differentiate a number of x squared, bring the 2 down and multiply it by the number. Now, 2 times 1.5 is 3. So you get 3x for that. And then this one, when you bring down, you have to differentiate this number of x cubed. Bring the 3 down. So it's going to be 0.025 by 3, which is 0.075. Fair enough. So it's minus 0.075 x squared. Okay, for that. Grand. So, and that wasn't that difficult. So I'm imagining, right, that there's 50 marks for this question. That's probably just given me 10 because they were both quite easy. Okay. Now, on the next page here, I'll just show it to you here quickly. on the next page, right, part B here, it says, okay, the height of a different plant may be modeled by a different function. And they're giving us P dash, which means the derivative, which is the rate of change, okay, of the height of the function. By the way, that's in millimeters, yeah. So that is the derivative there. But P dash of x we're given is 1.1 plus 2.73x minus 0.078 x squared for that. Okay. Now it says in your answer, give each value correct to the nearest whole number. Now it says, hang on, the question wants us to solve P dash of x is greater than 24. Now, well, you could try and say, yikes, what's this talking about? Well, P dash of x is a derivative. Yes, it is. And they want the derivative to be greater than 24. Now, you can focus on that if you like, but actually, P dash of x, as they've given it to us here, it's essentially just a quadratic. So therefore, what they're really asking us to do here is pure algebra. They want us to solve a quadratic inequality. So 1.1 plus 2.73x minus 0.078 x squared is greater than 24. Now, I'm just going to rearrange the terms here on the left-hand side. Put the x squared first, minus 0.078 x squared, then followed by the x term, which is 2.73. And then I'm going to bring the 24 over. Now, if I bring the 24 over to the left, it's going to become minus. So we get 1.1 minus 24, and that comes to minus 22.9. Sorry, that's an x. Yeah, that's an x. And then it's minus 22.9, and that's greater than 0. Now, the next thing here is that we have a quadratic, okay, greater than 0. However, when we're dealing with the quadratic inequality, we never ever like to have a leading coefficient which is negative. So what I'm going to do there is going to multiply all the way across by minus 1. And I'm going to get 0.078 x squared. Okay, and then it's going to be minus for that 2.73x. And then it's going to be plus for that 22.9. Now, very importantly, unlike with an equation, when you multiply an inequality by a negative, you have to reverse the order. So that's going to be less than 0. So now we go into solving that quadratic inequality there. And this is a little bit painful, and I'm just going to talk about it because I don't want to spend all the time on this. But you're going to have to solve the equation. Call that y, or just put the quadratic equal to 0 and work out the two values of x. So if you are talking about a quadratic curve that goes like that, 0.078 x squared minus 2.73x plus 22.9, that will be, okay, when you get that, that will be a U-shaped quadratic like that. And you'll get your two roots for x. And then you want this here to be less than 0. And that means below the x-axis. So the values in between the two roots that you get are what you're looking for. And then they said, give your answer correct, okay, to the nearest whole number. And that's fine. Now, the thing here is you have to recognize that it looked as if the question was dealing with derivatives because they gave you p dash of x. But actually, when you looked at it carefully, it was about a quadratic inequality. Now, the C part of this question, okay, changed again. So the C part of this question, I'll put it up on the screen here. The C part of the question looks this, and it says, the logo for this company is in the shape of this diagram here down below. And it says the logo is the region enclosed by the three curves, right, defined by the following functions. Now, C is the quadratic curve, C of x, I'll just write it down, C of x is equal to x squared. And then S of x is this curve here in the first quadrant. So the upper part of the logo there is given by S of x, and that's 2x minus x squared. And k of x, which we're not given, is this one over here. And then they asked you in part C, part 1, they asked you to work out the area of the logo. Now, they're very kind here, and they do say, find the area of the logo in the first quadrant, which is this one, and then double it. Now, this is an idea that's becoming more and more prevalent in recent years in Leaving Cert, to find the area between two curves. We can use what's known as the vertical strip method, and that is to imagine a vertical line going from the lower end to the upper end. Now, the lower end we call y1, and the upper end we call y2. And y1 here, okay, what's y1? y1 is c of x, whatever c of x is. We'll come back to that in a minute. And then y2 at the upper end is s of x. Now, we can work out the area between two curves like that by writing down the integral between 0 and 1, the two endpoints of the region, and then just integrating that vertical strip. And the reason that works is because mathematically what the method does is that it actually, funny enough, it makes the lower curve here it distorts it into the x-axis, and then it distorts the other curve correspondingly, so that all you're doing is working out the area above that. So in that case there, the area can be written down as area, right, of one particular section here is given by the integral from 0 to 1 of y2 minus y1 dx. Now you need to put in, that's only a formula. You can't work that out until you put in what y2 is. Now y2 is s of x. So that's going to be 2x minus x squared, and then minus y1, and y1 is c of x, and that's x squared. So then you just need to tidy that up, okay, dx. And when you tidy that up, then you can carry out the integral. That's not going to be the final answer. The final answer will be double that, okay? It'll be double that because it said here in the question, work out the area in the first quadrant and then double that. Now, the last part of the question, I'll let you finish that because we're going to finish in a minute or two here. But the last part of the question said to find out the equation of the curve k of x. And this is yet another change. They're talking now about transformations of curves. And the way to do that, to find the curve, and you're told here, I'll just read it for you first of all. Okay, it's here, and I'll come back to here and write it down here. But it says, the function k of x, which is the upper part of this one, can be written in the form of a quadratic. Okay, it says, find the value of b and c if it's in the quadratic. Remember that k is the image of s under axial symmetry in the y-axis. So this is transformations of curves. Now, if you want to get the equation of any curve, the typical way of doing it is to ask yourself, right, if xy is a typical point on the curve that you want to get the equation of, if you find the image of that point under the transformation, where does it go to? Well, if I think about that for a second, right, x would be the distance going back here to the left, and y is the vertical distance up. That x coordinate there will be the negative of this. For example, if that x coordinate there is minus a quarter, this one will be plus a quarter. So that point, where's my pen? That point there will just be minus x comma y. And this is how we get the equation of k of x. Say that this point, minus x comma y, satisfies the equation of s of x. So minus xy is on the line, on the curve, y is equal to 2x minus x squared. And therefore we can say that we can get k of x, okay, we can get k of x in the following way, substituting minus x in for x and putting y in for y. So you get 2 times minus x and then minus x to be squared. And if we tidy that up, that's going to be minus 2x, and it's still minus x squared for that. Okay, because minus x to be squared is just x squared. So that's minus 2x there for that. And that's that part of the question. Now, look at the different number of question parts that we've had so far. We've had a little bit of basic algebra, substitution in, then differentiation, then we had inequalities. Now we have integration, and then we have transformations of curves. And believe it or not, this question is not finished. Okay, it's not finished, right? Now, and how could you categorize this question? It's all over the place. The final part, and we leave it at that then after that. The final part is this one here. Okay, it says in the question here, it's part D of the question, and I'll tell you what it says. And by the way, this is an example of a question that it's very, very difficult to prepare for because it's not something that people are used to. It says here, in this part, P and R are constants. So P and R are real numbers, and R, we're told, lies somewhere between 0 and 0.9 P. Okay, not quite sure where they're telling me that. Okay. Oh yeah, okay. And they're still sticking with the idea of the company. And it says here, the company sells bags of food. The usual price for one bag is €P. And then it says, in a sale, the customer can choose to you pay using either option 1 or option 2 as follows. And option 1 says the usual price reduced by 10%. And then, so I'm just going to write down here, usual price, just so that we're clear. So usual price is €P. So option 1 is that we take the usual price and reduce it by 10%. Right, and then reduce that by a further or. And then the other option is to take the usual price reduced by or and then reduce that by 10%. And the question says, which option is cheaper? In other words, better for the customer. Okay, and write the answer for each one in terms of P and R. So option 1 is that you reduce this by 10%. Now 10% is 0.1. So the price will be P minus 0.1p, okay, because that's 10% of p, and then reduced by a further r. Now, 1p minus 0.1p, that's going to be 0.9p minus r. The other option that the customer has, according to the question, the other option that the customer has, option 2, is to take the usual price, okay, and reduce that by R. And then this new price reduced by 10%. So reduce that by 10% of P minus R. Now let's just work this out. So this is the new price. And then they said take 10% off of the new price. So we get P minus R minus 0.1p. But then we have minus minus is plus 0.1 R. And that's going to be P minus 0.1p is 0.9p. But then here's the difference. Minus R plus 0.1 R is minus 0.9 R. So actually, looking at that, option 1 is better because you're taking more away from 0.9p there than you are here. If, for example, R was, let's say, €20, here you're taking away €20 from that, but here you're only taking away 18. 0.9 by 20 is 18. And look at that. That one question ranged over so many different question types. And it's even hard to categorize that one there. Okay, and just say what that actually belongs to. Right, okay, so, well, we've gone way over the hour mark, and I did say, well, they did say that there was going to be time for anybody to ask any questions if you want to. It's up to you. You've been asking questions along. I'll give it a minute or so if anybody has any other questions, which you can type into chat. Okay. Um, there are lots of other things. Just to say that Yeah, whereas I do take classes here during the week, right, online. I do take live classes on a Saturday morning in the institute, and then on the Easter course, I do the live classes in the institute. I don't do the online ones. Right, let's see what this is. Do I have any predictions? No. The only prediction, I mean, this is going to sound trite, but the only predictions are I know the way their minds work. They're going to make as many questions as possible appear new. Okay. That's what they're trying to get away from, the idea of people being able to make predictions. They are as conscious of it as you are. Okay. Um, yeah, because of the range of topics in that question, would you recommend trying to avoid it? Not, it depends. I was quite happy with the individual topics, and the one thing that struck me about the question is that it actually wasn't very long. It was shorter than many of the other ones. So if you're able to mentally hop from one to another like that, okay, just the fact that it does, but this idea of pigeonholing questions, okay, um, and just saying, oh, this is a particular type of question, that's not a great idea, okay. Um, Okay. Well, just see another question here from Aoife. Will they take answer before method? No, they'll take method before answer. An odd time if you've got the answer, and it's very odd. If you write down the answer, if you write down the answer and you don't show where it comes from, if, for example, it's done on a calculator or whatever, yes, they'll take that. But if you pull a value out of the air, especially one that's quite difficult to get, okay, um, yeah, it's not going to be. You're looking for trouble, really. Do I think not being able to do differentiation integration is a sign to drop to ordinary? Possibly. Um, yeah, there's no integration on ordinary. There's a very, very small amount of differentiation. There's no first principles, and there's just differentiating polynomials on ordinary level. So yeah, if you don't need it for college, you can save yourself a lot of time that you can then use for other subjects. Um, oh, there's a question just come up here from Keelan that this is very, very hard to know because he said, I'll just read it. If you are halfway through a question and you realize it's longer than you thought and you're short on time, would you recommend to skip on to a shorter question? Again, is there a shorter question? Can you be sure that it is shorter, or does it just look shorter right now? Okay. You see, again, they will mark your best questions, but if you do half and half, all you'll do is get the better half. You might be better staying with the one that you're on and just getting as far into it as you can. Okay. Do you think people improve a lot after the mock? I definitely do, especially when teachers have time to start looking, as we've been doing here today. Okay. Um, at questions and how they manage to merge different ideas in the same question. I definitely do. How long would you recommend studying maths a week? I often get that question, and I'm sorry, I have to kick to touch on that one because I've had some really excellent students over the years. Okay, some of them went on to be professors of maths, and they could do their maths in about 1 minute a night. And it's really not fair to say that. Whereas other people, the rest of us just struggle and we spend our half hour or an hour and a half. Again, we have to divide all our study time between all our subjects. Okay. Um, so it really depends on how uh, where you stand with maths. Um, but you do need, in the time that remains now at this stage, to start identifying where your weaknesses are. And you'll be getting your marks back soon. Some of you may have got them already. You need to go through that and just see, what it shows in terms of issues. I wouldn't get hung up on the actual mark you got. It's more about learning from the mistakes you made and also, indeed, what you did well. Okay. Um, yeah, I mean, yes, okay. The DEB mocks are definitely harder. I did them years ago. I used to make them out years ago. Okay, I don't do them at the moment. Yes, but I mean, if you do the exam craft mock, you could try doing the DEB mock, but again, get guidance as well. In the sense that have a teacher or somebody look at it, okay, and see how you get on, okay. And it's not one of the things I keep on saying to students about revising questions. It's not doing as many questions as possible. It's not about quantity. It's about quality. If you do a smaller number of questions, okay, if you do a smaller number of questions But each time you do a question, you look at it and say, right, what ways could they vary that? What are the key issues in that? Okay, right, and so on. Um, yeah, okay. I definitely think it's better to do questions in quality. I often see people bombing through, and in particular, there was I don't know if you remember this, but in 2023 there was a very tough paper one, and there were numerous people in the media saying, "Oh, I had done all the questions and all the papers and all the mocks for the previous 10 years, and I thought I'd do really well, and I didn't." And the reason was because the paper looked different and people had learnt off questions rather than trying to understand the ideas. That's why I think do a smaller number and do them in more detail. Is it better to study maths 4 hours once a school week or 1 hour a day? 1 hour a day is better because you reinforce what you've learnt and it comes to the front of your mind again. And every time you reinforce it, it takes longer for it to go away. Whereas if you do it once and then it's a long time again before you come back to that idea, a lot of it may have disappeared. Where can you get the 2025 mocks? Um, I'm not quite sure. I think you can probably get them from some of the online sites, maybe Slutty Clicks, I don't know, or maybe your teacher has access to them. Okay, I'm going to give this one more minute. All right, if anybody has any other questions, and then we're going to call it a day. All right, if anybody has any questions there. Right. Okay. Well, look, all I can say is once again, very sorry for the postponement. There was a glitch with the IT equipment, okay, in the institute, and I had to rush home and kind of get set up here for 3:30. But thanks very much for staying with us all the way through this, and thank you very much. Okay. Bye. Bye.